I gotta watch my candle for flies on my head. Perma COVID here. How was the gas station next door? How was the gas station grocery store next door?
Surprisingly good store. I mean, functional, very functional.
I'm not shocked. I got a little bit of this left for you too, but I took all the others.
I've got a couple there with ice mixed with sink.
What's up?
No, I'm kind of over it. So.
You're over. This is going to take a half an hour. Don't worry. All right.
Yeah, I'm gonna need some lunch.
Hey, we're going to see who gets on in that time.
For those of you who just joined us, we're going to get started in 1 minute at the top of the hour. Thank you very much for your interest. We're going to have a good session today. And we'll get started, like I said, in just about a minute when it's exactly 10 o'clock in California. Good morning or good evening or good afternoon, wherever you are in the world. We're going to start our event now. Today's topic is using data science for SaaS and B2B price model optimization. It's kind of a mouthful, and it's actually changed a lot. The science of pricing has changed tremendously in retail, and it is currently changing heavily in SaaS and B2B. So let's dig into this. My name is Grover. I'm a data scientist. I really think of myself as a mathematician. My formal training is in math and topology as an undergrad, and then electrical engineering and quantum electrodynamics in grad school. I'm from the applied math branch of the family. Think plumbers, not John von Neumann. That's a nice picture of me. That's what my hair looked like back when I could go to a barber. Now my hair's much longer, but that's you can get over that. We turn the cameras on because people have requested it. Apparently with COVID isolation, people would like to see people's faces more. So we'll leave the camera on during this event, and you'll see me take a drink every now and then to keep my voice clear. I am a general mathematician, but I'm focused on business data. Business data behaves differently than population data, health data, et cetera. I have done some work in biogenetics, epidemiology, pharma, and finance, but I would say maybe 80% of the data I work on is some kind of business data from CRMs, ERPs, campaign platforms, commerce platforms, et cetera. We're going to talk about pricing as a science. We're going to talk about the difference between testing versus analysis. Testing is basically a set of methods. Anybody who's ever been in statistics realizes that a lot of the actual effort has nothing to do with the analytics you do. It has to do, did you do your test setup properly? We're going to look at popular models for software as a service, platforms for machine learning. We're going to talk about ethics and social media feedback, which is a big issue in price testing. Look at the biggest challenges. And we're going to then switch from SaaS to enterprise sales and how we do price analysis for enterprise sales. This event is being recorded. We'll send everybody a link to it afterwards. So pricing as a science. Basically, published studies on pricing go back to the mid-1980s when yield management migrated from oil and gas and manufacturing and made its way into business inventory. There were very few published pricing science models before the mid-1980s. There was significant work done on pricing as a science by Ogilvy, Benson, and Mathers. They did serious research, and other advertising and marketing firms did, but it was all kept as a trade secret. So there were very few publications about pricing as a science prior to the mid-1980s. The list of references for pricing as a science is pretty good on Wikipedia. I've copied and pasted it below, but all you have to do is go look at pricing science and you can go find it. I'll give you one caution. The yield management branch, which is the 1980s and statistical branch, use a lot of older process equations that are rather outdated. We've updated most of what they were using with modern data science models, and I'll give you a list in a minute. One of the surprises is how little attention is given to price optimization. There's a whole bunch of studies on whether companies have or have not done price optimization. And in general, most companies do not spend much time on price optimization. And the biggest motivation for price optimization apparently is the introduction of a new competitor into your ecosystem, wherein that competitor prices substantially less than current offerings. And then there's a flurry of price investigations. But in the absence of a new competitor, people don't spend a lot of time on pricing science, which is a mistake. And we're going to look at a couple of different outcomes for pricing optimization. A lot of people think that the goal for price optimization is quote unquote the highest volume of sales, which is what we will call market share. You can optimize for several things in pricing science, and we'll dig into that. So let's differentiate testing versus the analytics. The analytics is going to be done with data science models. The testing or the data collection is basically some kind of setup in your price presentation. And I've got bad news for you people in SaaS. You can't test pricing by saying, call us. In order to test pricing in a software as a service environment, you're going to have a pricing page. That pricing page is going to have to present a stripe of prices. We'll talk about stripes in a minute. What you do is you set your price ranges. We call them stripes. You say, I'd like to test these different points. And I'll say I usually like to prefer to test 5 to 7 total prices. In general, I can certainly imagine wanting to test 20 prices. I haven't actually seen such a study in years. But we like to test 5 to 7 prices in stripes. We'd like to have a couple of midpoint areas and then the outlier prices. We would like to offer these randomly to prospective buyers. Basically, you want a big buyer population. So for example, if you want to do price testing on much smaller volumes, the first part of this presentation is not going to help you. You're going to have to go to the historic pricing, which we will cover here. I just want to make sure you understand, if you sell dozens a month, let's say 100 units a year, you can't do price testing the way we're talking about it here. Okay, with that Cassandra-like warning, what you want to do is you want to know which ones they selected and which ones they actually pushed the buy button. Both of those are important. We're going to show those in tables. You want to test for significance. I would test for significance using the very old school statistical models. I like the chi-square test. You can have your own preference. You need to be ready for the lowest price to not be the winner. Value perception is complex. I won't show you pictures of the human hindbrain here, but the fact is that biases towards pricing are partly logical and partly non-logical. They're hindbrain, they're intuitive, and we're testing for both. And I'll show you how we test for both in just a minute. You want to keep the range of popularity, focus in on differentials between cart preference and buy preference. I realize that for SaaS, it's frequently not cart, it's free trial. Let's just use cart as a general term for they selected it. I realize that a lot of SaaS products don't look like it got put in a cart, but enough do that we'll stick with the cart analog analogy, even if it's not really a cart there. Okay. There are a fair number of popular models that have been published for pricing optimization and optimal pricing models. I promise you, these work just as well for SaaS pricing as they do for e-commerce products like socks and toys. I promise they do. It's the same basic set of equations in there. And you can use any of these as you want. And you can they work similarly enough that if you want, you can almost pick these based on your technology preferences. So for example, I've deliberately given an option. You can do this in R, you can do it in Python, you can use Spark, you can do that. There's a lot of different technology approaches here, and you're not going to get a huge difference between these because they're using the same family of curves underneath. Then after you get success, after you find your most common price, we then substripe. And we're going to look at examples of substripe. So in case this seems a little abstract, don't worry, we're going to get into hard numbers in just a minute. But after you've got an optimal price, which is basically a logical economic price, you then want to retest for emotional subprices. And there's this very long story, and you can imagine what we went through to figure out that for a particular SaaS price, 37.37 actually worked better than 37.00. It's hard to believe, but we had the volume to test it, and we know that patterned number did better as an optimal price after we found the macro price, which, as I remember, was $37.49. So we were testing for boundaries around $3,749, which was the optimal price in the first testing, and then we came to striping, and we found this. Okay, so remember, first we test with stripes, 5 to 7 stripes, then we find the best for our purposes, and the best for our purposes depends on our purpose. We may be optimizing for margin, we may be optimizing for market share, etc. So let's get into that. So we picked a product here. It's a SaaS product. I can't name what it is. It is a reasonably volume product, and basically it has one producer, and there's some white label people who resell this. So this SaaS product is sold under more than one name. Nominally, it's a $4,000 a year license. Now, there's this big thing up in the corner that says UOC. UOC stands for unit of consumption. I'm not going to show you a bunch of slides on unit of consumption, but it is essential that you get your unit of consumption right before you go pricing. What is a UOC? Let me give you an example of the company, a SaaS company that got it right the first time, and it's natural for them, and that's Salesforce. Salesforce has a unit of consumption of 1 person per month per seat. And so your price can go up or down depending on volume and features, but the unit of consumption is 1 person using the product for 1 month. Now, will they sell that to you? No. They will only sell you 1 year. But it is price and price presented per month, and that's fine. UOC, getting the UOC right, and I'm an evangelist for UOC. I've said here I'm the Johnny Appleseed of UOC in Silicon Valley. Getting the unit of consumption right before you price test is essential. It's outside the scope of this discussion. So let's assume that you've gotten your SaaS product brilliantly. You can explain it to an 8-year-old why you partition it this way. You license it in gigabytes, hopefully not, or something else, and that's your unit of consumption. So you got that all sorted. Now you got your price testing. Now I promised to show you some real numbers. This is an example of a price test, and the green stripe there will show you we're optimizing in this particular case for market share. Optimizing for market share and optimizing for volume is the same thing. And so what we found, and if you look across there, you can see our price stripes are to the left. How many times they were offered is in the next one, gross offers. How many times it went to cart select. In this particular case, by the way, it wasn't really a cart select, but we're bringing the same models we use in e-commerce over to SaaS commerce. In this particular case, it was free trial start. And then the conversions to actual purchases, you can see there, purchase select, which is the same as hitting buy or ka-ching in a cart. In an e-commerce world, the time difference between cart select or free trial and purchase select is a matter of seconds. In this SaaS world, it's a matter of weeks. But in both cases, they're short enough that you can optimize the same data end to end. It's not like it's 6 months between a free trial start and purchase. Okay, so what we've done here is we've looked for who picked the largest cart select, and you can see there, we won there, and then what was the purchase select, and you can also notice the prices below that didn't win. You can see very clearly that the lowest price had the highest cart select, $29.99. We're $800 difference between that and the best price. Why? Because more people picked it, but they didn't end up buying it. Why not? Value perception is a very complex thing in the human brain. We're not going to fire up the electroencephalograms here and measure their brain waves. We're going to do it the way you're seeing it. We're going to offer people prices. They're going to pick the prices. Then they're going to become buyers or not buyers. By the way, we've normalized for everything else here. There's no other biases in here. Those gross offers were made statistically very randomly. Okay. Then we marked substripes. We said, okay, we got our best price. Our best price is $37.99. And then we want to come in here and test some sub prices. And we tested several. We actually did test 37. It just doesn't show here. 37.67 won in this particular case. Basically, it had the highest purchase rate. What in the world is the difference here? The difference between $37.99 and $37.67 and $37.50 in dollars is really nominal. It's a rounding error. But if you do price testing and you have volume, you will almost always find that there's some subtlety to magic numbers for prices. You have to test a fair number. I'm sorry this is true. I know everybody wants this to be logical, but if you think that corporate purchases are made completely logically and that consumer purchases are all emotional, I promise you there's a fair amount of emotion you can detect in corporate purchases. So here, market share winners. This is the market share winner. This is the market share winner for the substrates. Now let's change topics a little bit. We also have gone in here and we got the cost of goods sold. Now, and that is third from the right, called COGS. If you've never heard the term, I would urge anybody who's doing this kind of price select, please learn how to talk like a little bit like someone who does an income statement, because you're really affecting the income statement. Price testing is a microcosm of income statement management. It's outside the scope of this discussion. Cost of goods sold is frequently burdened with things you wouldn't normally think of if you're an engineer or mathematician. Cost of goods sold frequently includes things like penalty for reserve, warranty reserves, the cost of putting a label on the outside of a box, not so much with SaaS products, but the cost of concluding the contract, the cost of paying for the credit card swipe, whatever it is, it's supposed to be in COGS. And you'll notice that COGS column is the same darn number, the whole stack. That's because you're selling the same product. And so the cost of the product, and you can also see down there for our lowest price, why we didn't test prices much cheaper than that, because we wouldn't make any money. So, and I know a lot of people think, well, if my volume goes way up, my COGS go way down. You know, it's kind of funny, even in SaaS, not so much. A lot of the costs are overheads in the company more than the technical provisioning of the actual service. Okay, so with that speech over, what you can see, and let's go back and remind ourselves, our best margin price, our best market share price was $37.99. Our best margin price was $44.99. We're using the same data. It's the same cart selects, the same purchase selects, and you'll notice those purchase selects were not the highest number. But that particular purchase select price actually caused the greatest margin. If you're going to do price testing, again, you didn't have to run a separate test. This is just inserting the COGS into the analysis. That's all we've done here. I haven't run a separate test. You need to give both of these to the product management, the finance team. You need to make sure very, very senior people in the company see this stuff. Why? Because the company's strategy needs to determine, are we optimizing for market share or margin? Now, let's drag this into the machine learning space. How did I implement my tests? First of all, I had to have a pricing page, and I started this discussion by warning you, if you want to run price testing without a pricing page on your website, you're going to fail. You can't test it unless you show people and let them select from it. So you have to have a pricing page. You have to have an offer randomizer. And you have to have a cookie so that if Joe Smith comes back 4 times, Joe Smith always sees the same price. And so you have to have association logic that remembers the people. And I realize this is imperfect, but basically you have to randomize the prices up front. Do not run a randomizer for every visitor. Everybody knows randomization works very poorly for one-off instances. Pre-allocate a huge number, 10 times more than you think you need, and just use those for the next visitor. The next visitor gets index 51. 51 has this price. The next one after that is 52. They get this next randomized price. Offer them these randomized prices. Display it on the pricing page. track how much time it takes to go from that into either the cart or the free trial. And I realize a lot of SaaS is not buy it now, it's free trial it now. That's fine. So we get into the cart or the free trial, and then we measure it and keep everything in a proper database. We like Snowflake. We also use Redshift in S3, in Amazon. So you can use whatever you want, but make sure it goes into a proper database, not just into a log file. One of the reasons is because your website can drop your log files. If you're storing all this in a container locally and your container gets resent, your log files can go away. Please store it in a proper database. Okay, I hope this makes sense. Basically, visitors come, different visitors see different prices. You measure how many people who see a certain price move to the next step. Pretty simple stuff. Then you have to model it. And one of the things we have to model for is there's a lot of variations. And this is where even though the process of SaaS buying is a little more blind than e-commerce buying, and I'll explain that in a second, you still have to model the shopper. You can model them by region. You can model them by a lot of other things, by some of the stuff they select, for example. But basically what you're looking for is you're looking for a model that fits the best outcome. And the best outcome, as I said, primarily is either going to be best market share or best margin. And what we like to do is we like to do this in a loop where we use Snowflake to store the data and then Zeppel to do the analysis using a commercial grade notebook, a data science platform that's kind of complete. You put it into the notebook, you run models against it, you get the results, you see the visualizations, but you're training a model. And we're going to use that model in deployment. You can have a lot of non-standard goods and services. If you've got the volume, you can test even non-standard. For example, in the SaaS model, you can have variable consumption where they see more than one price. They see a platform price, and they also see, for example, a consumption price, gigabits, end users, whatever it is that's the variable consumption part. And you can have unique service pricing. Some people charge more for different kinds of databases. A typical example is some SaaS products may charge you one price, for example, for an Azure database and a different price for an Amazon database. And we see these all the time. They're slightly different prices, and that can affect this. So this gets complicated. And now you can see why using models. So back when I was pretending this was easy, I was using a spreadsheet to make it look easy. The same thing isn't really true in the SaaS environment. In the SaaS environment, I have a bunch of things, a bunch of moving parts, and I want to model all of those, but I want to get the results I showed you here. I want to be able to see highest market share, highest margin, and what model delivers those. Now, to make this even more fun, you got different things that can happen, things like time of day. Even in SaaS commerce, we find things like people have a different price sensitivity when they're shopping on weekends, even for SaaS products, believe it or not. Different price sensitivity on weekends than they do on weekdays. And so you want your model to be tracking that. Now, your price testing. When you're all done, you'd like to get to the idea that I got a model that offers the same price. So if you think to yourself, no, I have to have one price. I always have to have one price. Airlines haven't had one price for the same product for years. So a lot of SaaS products have different prices. I know you may not think that's common. It's more common than you think, but you want to make sure you're ready for pushback. For example, two people looking at the same product at the same time, right next to each other. And people who will screenshot their price and push it to a big crowd. Social media sees these things, they go crazy. What this really means is you have to have the volume to price test pretty quickly. You can't push a price test out and have that price test running for 6 months, because at some point you're going to get a social media disaster. So price testing has to be pretty quick. There's also an ethics issue. During the price test, what we normally do is, and that's why it says don't be evil, what we normally do is we take them all the way to when they're buying, and then at the very last minute, we give them the best price. That way, no buyers during the price test get an actual different end price. They all get the lowest price that was offered. Again, another reason why you don't want this thing to run but so long. If you've never run a price test, I promise you, if you don't do it this way, you'll be sorry. It's a well-known problem. Don't be the next person who has to discover that actually running a price test and selling the final purchase at different prices can cause a social media disaster. So the time of the study, again, you need the volume. Shorter is better, or forums will tell people to game your pricing. They'll start calling your phone number to ask for the lowest price posted on the forum, even if they can't see it on the pricing page. Okay, price testing. Price testing is sensitive stuff. You're dealing with commerce data, you're dealing with individual knowledge data. You've got a lot of issues. And the issues are things like security. I don't want my data on roving laptops. I don't want my secrets files with passwords everywhere. I'd like it to be able to scale. I want to be able to share models with my teams, but I don't want to share all the secrets, etc. So you got a lot of issues here. On the other hand, you want round-trip collaboration. You want people to be able to share models and work across a team. So what we're looking at here is a way to do this in a notebook. And so what we have a preference for is, we have a preference for staying in a notebook, and we'll get to that in a minute. Now let's switch topics to not SaaS. I've got regular old products that are sold in a B2B licensing model, and I need to do price optimization. Here's the bad news. You can't sample at volume. I don't care even if you're a big company and you've got tens of thousands of sales, you probably can't randomize the price presentation. You can't get sales to cooperate in a price test. You have to sample it from historic data. And the data science models aren't going to save you here. The good news is there's been a lot of success with augmented proposal data. That is in your systems, and this is where you have to be a grungy plumber of a data scientist. You have to go get the proposal data out and run it through models there. The good news is you can run a long-term study. With regular price testing, you can only analyze a relatively short window before the negative feedback of price testing gets to you. You can run very long-term studies. The longest I've run is a 24-month price optimization model. What you do is you capture proposals, quotes. They're called quotes in the CRM. You convert the table data from quotes into data frames and notebooks. You can go back 18 months. You can go back 2 years. You can track per unit price offered. So what you want to do is you have to reduce it down to a common product you're testing. You have to know the product numbers, the per unit numbers, and you have to normalize for the size of deals into the slices. Now you're creating slices here again, but it's not your price desires. You have to group the sales by size, because you're going to get a different price optimization at different prices. And you look for relationships between the close rates and the price. Again, here, you could, again, optimize for both market share, revenue, or margin. And it depends on what you want to do. At a low volume, all this is going to yield hints. At Oracle kinds of volumes, where they sell hundreds of thousands of units a year, you get a real curve. You get a strong mean square. That should be RMS, not RSM. RMSE. You get a real strong RMSE, which is the low error rate of a model fit. So let's pick on Salesforce. How we do this in Salesforce? Well, you have to have someone a data engineer who knows how to get the data from Salesforce. You have to get only 4 tables: the account table, so you can profile the customer, the opportunity table, and you want to look primarily for new business. Please don't try to do price optimization for renewals unless you've got a heck of a lot of data, but you can do it. It's just a separate kind of study. Normally, we're looking for new business. You want the quote table, which are related to the opportunities, and different companies have huge variances here. Some people will produce as many as 30 quotes for opportunity, but one of them becomes what's called the primary quote. That's the one that's hand selected to win. Go ahead and put that in there. That gives you the price optimization. And then you want the product catalog. You need 4 tables. You use some kind of ETL process from Salesforce to get it into Snowflake. Frankly, most companies use things like the Salesforce data loader to pull the tables down, dump them into Snowflake. Now you've got the data in Snowflake, and you can run the model deploy retrain loop. So you've taken your ETL data out of Salesforce, you've put it into a proper database. It could be Snowflake, it could be Redshift, it could be a lot of other things. We recently did this with an Azure SQL database. It all works fine, but you want a good database. You pull these in, you model them, and you're modeling it for the same purposes. And you could use a neural network here because you have more data than you have in the SaaS world. The reason you have more data, if you remember, you're pulling in the account table, you have customer profiles, you have information on industry, on company size, on revenue, number of employees, geolocation, lots of other things. And so you can build a multi-layer model here, go optimize for the results, margin or market share, being the typical price optimization, margin, revenue, and market share being the three choices. Again, use a proper database. We do this a lot in Snowflake. I usually prefer to have something that's closer to an SQL database because it's much closer to the data science model. The data science model is usually some kind of data frame, which is row column. If you have JSON heap data, you can in fact pull that into data frames, but it's a different kind of analytics. So you just basically have to convert the JSON data. When you move from modeling towards production, you need an ETL model for working data and live data. So when you did this, you were using historic data. It doesn't have to be live data. You don't even have to use current data, although you want it to be near time enough that it's going to reflect the current model. So once you've done that, now you've got your model in there. You go to a live model and you want to be able to retrain it with current data. And so you have to have a refresh from the historic. Again, use a proper database so that you can get to the data and make sure you're sticking in this notebook world so that you can collaborate. One of the things you don't want to do is you don't want to have to give everyone in the world access to your database so they can verify the results. If you share a notebook, you can share the results without sharing the data. That's why I'm saying stay in the notebook world. Zeppel is the notebook we're using for this. It works really well. Basically, notebooks are the new Excel. Sorry about that if you don't like that term, but it's really true. They're becoming ubiquitous. Therefore, use a good one. And that's why we're using Zeppel. It's hardened. It's cloud-based. One of the nice things about all this is the data science you're doing today usually stays in the cloud. It doesn't come to home machines running GPUs. It's all processed properly in the cloud. It's all secure. It scales better. It scales across geographies. It scales across teams. You can vary the security, visibility, and changeability between people. You can collaborate. It's got a better CI/CD model. It's just a better model overall. So that's kind of it. If you've got any questions, you can put them into the question panel. I do have a question here on, what kind of resources are required for this. This kind of data science is not super resource intensive. Even a large SaaS offering is going to get, a few thousand free trials per day. That's heavy. And you can handle that in smallish containers, smallish databases. It's not like Amazon. You don't have the problem of, 200,000 events per minute and that kind of thing. Typically, you're tracking, fewer than 100 events per hour. You go into the database and you can model it, after you've collected enough data. Another question here is why did I mention security so much? Well, this stuff's sensitive stuff. You're talking about, the most private and intimate part of a company is often, are we actually going to optimize for market share or for margin? And that is a strategic decision. You really want to keep that within the confines of the company, usually within a small group. So a whole bunch of notebooks on a whole bunch of laptops and not keeping the security profile is pretty important. At the same time, you usually want more than one data scientist, and you also want the product marketing people in on this and the finance people. So sharing notebooks in a controlled way is really important. So that's why I emphasize that. I got another question here about how they love to put their log data into flat files and then just parse it later. That's fine. but you're going to be doing a lot of data conversion. And that's why we actually prefer, particularly when you're going from historic data to live data, it's nice if it goes into, if the events go into the database already in some kind of square row column format, even if we have to do a relational join, because then we're one step away getting into the notebook. We have found a fair number of what we call practice errors and process errors when everyone is doing their conversion of heap data to row column data differently. You get differential results. I hope this has been useful. We're past the half-hour mark, so I'm going to go ahead and end this event now. If you have any other questions, feel free to email me. My email address is there. It's grover@zeppel.com. We also, if you want to see a demo, you can email demo@zeppel.com. It's useful to see. I haven't done a demo in this event because we had a lot of other what I call process and strategy things to discuss how we attack these problems. In the future, we can hold a live demo and I can show some models converging on best margin, best market share, best revenue kinds of data modeling around pricing. Thank you very much for your interest, and I'm going to end this event now. This event's been recorded, so we'll send you a recording. Thank you very much and have a great day.